Measures of variations. What do you mean by measures of variation? Any idea what is measures of variation? Any idea what is measures of variation? What is measures of variation? I think you have this when you were in junior high school. So what's the measures of variation? Any idea what's measures of variation? Measures of variation. What is it? When we say measures of variation, another term for variation is dispersion. Miss, what do you mean by dispersion and variation? When we say variation or dispersion, you are measuring the spread of the scores. Okay? The spread of the scores or the spread of the data. Are they too far to each other or too close to each other? So that is variation or dispersion. You are measuring the spread of the data to each other. Are they too close or too far? So that is measures of variation. Okay? So measures of variation. So for example, this is the scenario. A testing lab wishes to test 2 experimental brands of outdoor paint to see how long each will last before fading. The testing lab makes 6 gallons of each paint to test. Since different chemical agents are added to each group and only 6 cans are involved, these 2 groups constitute 2 small populations. So given are the time that paint lasts, okay, in number of months. So paint A, so the brand is Boy Band Paint. So these are the number of months that it will last. 10 months, 60 months, 50 months, 30 months, 40 months, and then 20 months. David Paint, okay, so these are the number of months that the paint lasts. 35 months, 45 months, 30 months, 35 months, 40 months, and then 25 months. Without computing, just try to analyze the table. What can you say about the spread of the data to each other? Compare the first paint, Boy Band Paint, and then David Paint. Okay? Try to analyze the given table that we have. What have you noticed in terms of their spread of data? Try to examine. Are they too far? Are they too close? Try to examine. What have you noticed in terms of the spread of the data? And that's already variation. Again, we say variation or dispersion, you are measuring the spread of the data to each other. So in this particular table, try to figure it out. What can you say? And then? Okay. Yes. Very good. So in letter A, they are too far, right? And then in letter B, they are quite closely to one another. Okay? So that is the explanation of the given table. But how do we measure, or how do we measure their spread to each other? Okay? Or how do we measure the variation or the spread of data? Okay? So to solve for the mean, so we have summation of x over n, so you have 35 months. Then brand B, summation of x over n, still 35 months. Since the means are equal, can we conclude that both brands of paint last equally well? Yes, of course, because the means are equal. Okay? Below is the graphical representation of the data set. What can you say about the 2 brands of paint based on the graphs? Okay? It was explained by your classmate a while ago. So brand B, they are too close. And then brand A, they are far to each other. Okay? Based on the graph that we have. So let's proceed now. So measures of variation. To describe the data set accurately, it is not enough to simply use averages or measures of location. We need additional measures, such as the measures of variation or dispersion, to describe further the data set. Okay? Or in short, when we say measures of variation or dispersion, you are referring to the spread of the data. Okay? So how do we measure variation? So we have range, interquartile range, variance, and then standard deviation. Okay, so to measure the variation or the spread of the data, we need the following. Okay, we need the following. So we have range, interquartile, variance, and then standard deviation. So when we say range, the range is the simplest measure of variation. So highest value minus the lowest value. So range, highest value minus the lowest value. Okay, so for example, in the previous example that we have, paint A, paint B. So how do we solve for the range? Find the range of the 2 brands of paint. So range is equal to the highest value minus the lowest value. So range paint A is equal to 60 minus 10 equals 50. Range of paint B, 45 minus 25, that will be 20. Okay? Try to examine the answer of the range. Okay? So in paint A, the range is 50. Range B, that is 20. So if you have noticed, 20 is too close to the given data that we have. So they are too closely to one another. Okay? Next, what about population variance and standard deviation? So the population variance and standard deviation, this is the formula. So the variance is the average of the squares of the distance each value is from the mean. The symbol from the population variance, we're using the sigma squared. Okay? Sigma squared. So sigma squared is equal to the summation of x minus the mu squared over n. Sigma squared is equal to the summation of x minus the mu squared over n. X, you're referring to the individual value or the individual data that we have. Mu, you're referring to the population mean. N, you're referring to the population size. Okay? Then the standard deviation is the square root of your variance. Standard deviation is the square root of your variance. So the symbol is this one. So try to familiarize with the symbol. The square root of summation of x minus the mu quantity squared over n. Okay, so that's for population variance and standard deviation. Okay, what about sample variance? Okay, so the sample variance, the formula is s squared is equal to summation of x minus the mean, the sample mean, squared over n minus 1. Okay, if the problem deals with sample, so we will be using this one, this symbol. Okay, x bar referring to the sample mean, and you're referring to the sample size. Okay. So formula for the sample standard deviation, just simply get the square root. Okay, simply get the square root of your sample variance. To determine the sample standard deviation, just simply get the square root of your variance. Okay. Miss, how do we use sample variance or sample deviation? So it depends on the problem. If the problem says that the given data is a sample, then we're going to use sample variance and sample deviation. But if the problem says it's a population, so we'll be using population variance and population standard deviation. Okay? So what is a standard deviation? It's a measure that is used to quantify the amount of variation or dispersion of set of data values. Take note, a low standard deviation indicates that the data points to be close to the mean, also called expected value. Okay? A low standard deviation indicates that the data are too close to the mean. Okay? While the high standard deviation indicates that the data points are spread out over a wider range of values. So meaning they are too far to each other or too far to the mean. So that if the standard deviation is higher. Okay? Again, take note, a low standard deviation indicates that the data points is to be close to the mean, or we call it expected value. But if the standard deviation, okay, is higher, then the data points are spread out over a wider range of values. So that is the interpretation of the standard deviation. Okay? So these are the key points. Standard deviation is a measure of variation of values from the mean. The larger is the standard deviation, the more data varies. Okay? The more data varies, meaning are too far. Okay? Too far to the mean. Okay? So meaning they are more variable. Okay? The value is more, they are more on variability. They varies more. If the value of the standard deviation is higher, they varies more. Okay? The unit of standard deviation are the same as the unit of the original data values. Okay? The value of the standard deviation can increase dramatically with the inclusion of one or more outliers. So for example, variance and standard deviation. Okay? Find the variance and standard deviation of the two samples of brands of paint. Which brand is more spread? Okay? In this particular, so the answer is point A is 2.91. So that's the variance. And then the standard deviation of the population is 17.7 or 17.8, 0.08. Paint B, the variance is 41.67. And then the standard deviation is 6.46. Now the question is, which brand is more spread? Is it paint A or paint B? Okay, A. Why is it? That's correct. Okay, because the standard deviation is higher. If the standard deviation is higher, then it more varies. Okay, it more varies. So that is paint A. If you're talking about the spread of the data, okay, if you're talking about the spread of the data, of course you need to choose the larger standard deviation value, okay, which is paint A in this particular. Next, the number of incidents in which police were needed for a sample of 10 schools. Okay, the word sample, meaning this problem deals with what? Is it population or sample problem? Is it population problem or sample problem? Okay, sample problem. Why is it? Because of the word sample of 10 schools. Okay, so sample of 10 schools. So these are the given data that we have: 7, 37, 3, 8, 48, 11, 6, 0, 10, 3. Find the range, variance, and standard deviation. So in this particular, how do you solve for the range? How do you solve for the range? Okay, highest value minus the lowest value. So what's your lowest, what is your highest value? 48, and then the lowest value is 0. So 48 minus 0, so what's the range? 48. Now, what about sample variance? How do we solve for the sample variance? Summation of x minus the mean, sample mean, quantity squared over n minus 1. Okay? So how do we solve for the sample variance? How do we solve for the sample variance? How do we solve? We do have the formula. So how do we solve it? How do we solve for the sample variance? Okay, get the mean. So what's the mean? What's the mean? Then I'll teach you how to solve it using the calculator. So what's the mean? How do you solve for the mean? How do you solve for the mean? How do you solve for the mean? Get the summation. Okay, summation of everything divided by what? Total number of sample. Okay, how do you get 13.3? Okay, add everything and then divide it by 10 because the number of sample is 10. Okay, so that is the mean. Now, how do we solve for the sample variance? What's the formula for sample variance? Summation of x minus the mean, sample mean, quantity squared over n minus 1. Okay, n minus 1. N minus 1. So what is the answer? What is the answer? What is the answer? Summation of x minus the mean, okay, quantity squared, all over n minus 1. N minus 1. Okay, n minus 1. First, ano yung first? 7 minus 13.3 squared plus, ano yung next? What's next? What's next? 37 minus, okay, minus 13.3 squared, quantity squared, plus, what's next? 3 minus 13.3 quantity squared, plus 8 minus 13.3 quantity squared, until you reach what? Until you reach what? 3 minus 13.3 quantity squared, all over n minus 1. N minus 1. So what will be the answer? 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 What's the correct answer? This one is wrong. It's not 271. Give it the correct answer. Can anyone give me the correct answer? It's not 271.78. That's wrong. So give me the correct answer now. What's the correct answer? What's the correct answer? Is it 271.78? Get your calculator and then solve for the sample variance. Just get the summation of everything and then divide it by n minus 1. Why is it n minus 1? Because we're talking about sample. Okay, we're talking about sample. So it should be n minus 1. Meaning, when we say sample, that's the part of the whole. A part of a whole. So that would be n minus 1. Very basic. So what's the answer? What's your variance? Sample variance? Is it 271.78? Is it? Can anyone give me the sample variance? After you solve everything, can anyone give me the sample variance? Okay, very good. That's 254.67. That's the correct answer. 254.67. Now, if that is your sample variance, what is your sample standard deviation? What is your sample standard deviation? What is your sample standard deviation? How do we get the standard deviation? Just simply get the square root. Okay, so what's the answer? Okay, 15.96. 15.96. Okay, so that's how we solve for the sample variance and sample standard deviation. Okay, Miss, what about using the calculator? How can we use it? Okay, how do we use that using the calculator? Okay, so I'll let you know later after we discuss everything. Okay, next. Interquartile range. Okay, interquartile range. So to solve for the interquartile range, okay, quartile 3 minus the first quartile. Okay, third quartile minus the first quartile. So that is interquartile range. Okay, so interquartile range, third quartile minus the first quartile. But the question is, Miss, how do we determine the first and third quartile? Okay, so we will find it later as we go along. So note on the symbol. Mean for the sample, that is x bar, and then for the population is mean. For the standard deviation, S for the sample, and then sigma for the population. Variance, S squared for the sample, and then sigma squared for the population. So please take note of this. Measures of position. Okay, measures of position. When we say measures of variability, what's the concept of measures of variability? You're measuring what? Measures of variability. You're measuring the range or the spread of the scores, right? When we say measures of variability, you're measuring the spread of the data. Okay, the spread of the data. What about measures of position? When we say measures of position, from the word itself, okay, let's say for example, you need to determine the top 25% of the class, the top 30% of the class, below 75% of the class. So that is measures of position. Okay, where is the 38th? Or the 28th in the class. Who's the 28th in the class? Who's the top 10 of the class? So that's our measures of position. Okay, you want to determine the top 20 or the lowest 75 of the class. So we'll be using measures of position. Okay, from the word itself, you're measuring the position of the data. The 75th position, the 25th position, or the top 25%, or the lowest 75%. So that's a measures of position. Okay, let's say, for example, you want to take an entrance exam in your in a certain university. Okay, they're using the percentile rank, right? They want to determine the top 25% of those examinees. Okay, so are you included in the top 25%? So it depends on your score. That's why you're using measures of position. Okay, they're using percentile rank. They need to rank your score if you belong to the top 25% of the examinees. Because some of the universities, they usually get only the top 25% of the examinees. Kaya yung 75%, even though they want to be part of that university, but the cut-off is 25% now, kaya they're not allowed to enter that university. Okay? So if you want to determine the top 25% of the examinees, we're using measures of position. So that's the application of measures of position. Okay? Let's say in the ADT, you want to determine the top 10% of the class. So we need to use the measures of position. Okay. So measure position, in addition to measure of central tendency and measures of variation, there are measures of position or location. This measure includes the standard scores, percentiles, deciles, and quartiles. They are used to locate the relative position of data. Okay, again, what's the concept of measures of position? You are measuring what? The location or the position of the data. Okay, location or position of the data in the data set. Okay, location or position of the data in the given data set. So that's quartile. 4. Okay. Okay, very good. Okay, so percentile, the data set into 100 equal groups. Decile, separate the data into 10 equal groups. Quartile, the data set into 4 equal groups. Okay, so quartile, decile, percentile. A percentile rank for a data set represents the percentage of the data values below the data set. So for example, if a value is located at the 80th percentile, it means that 80% of the values fall below. Okay, fall below it in the distribution, and then the 20% of the values fall above. Okay, fall above. So that's the percentile rank. For example, if a value is located at the 80th percentile, so what is the interpretation? Meaning, the 80th percentile, that will be the 80% below, okay, and then the 20%, the values fall above. Okay, 80% below and then 20% fall above it. Okay? The median is the value that corresponds to the 50th. Okay, 50th. That's because it's a middle percentile. Since one half of the values fall below it, and then the other half fall above it. So that's a median. Okay, the 50th percentile. So how do we solve for the percentile? Percentile, number of values below x plus 0.5, then the frequency of x, then divided by the total number of values. Okay? If you want to determine the percentile rank of that particular value, you need to use that one. Percentile rank is equal to the number of values below x plus 0.5, okay, multiplied by the frequency of x divided by the total number of values. So for example, a teacher gives a 20-point test to 10 students. Okay? A teacher gives a 20-point test to the students, 10 students. The scores are shown here. So find the percentile rank of a score of 12. Okay? Pang ilan daw si 12 in short? Okay? So these are the scores. 18, 15, 12, 6, 8, 2, 3, 5, 20, and 10. Okay? So pang ilan si 12? So that's the percentile rank. Okay? First, arrange the data from lowest to highest. So we have 2, 3, 5, 6, 8, 10, 12, 15, 18, 20. Okay? First, arrange lowest to highest. Okay? Next, substitute. So what is the percentile rank of 12? Okay? The score of 12. Pang ilan daw yun, yung score na 12? Okay? Number of values below 12. How many number of values below 12? Okay, 6 plus 0.5 multiplied by how many? How many yung 12? How many 12 appears in the given data? Ilan daw yung 12 na 1? So 0.5 times 1 because it appear only once. Okay? Divided by total number of values, which is 10. There are 10 students. Multiplied by 100. So therefore, a student whose score was 12 did better than the 65% of the class. Okay? A student whose score was 12 did better than the 65% of the class. Okay? Because the percentile rank of 12 is 65th percentile. So what is the interpretation? So meaning, the scores below 12, what? Are the 65% below of the class. Okay? So in short, in other words, if your score is below 12, you are included to the 65% of the class. Okay? And then the 35% na score, yung above 12. Okay? If your score is above 12, you are belong to the top 35% of the class. You get the point? Do you understand, people? Okay. Now, the question is, what if we're looking for the percentile? Let's say, what is the percentile 25? What is the percentile 65? Okay? So, yung reverse naman nito this time. How do we solve for the percentile 25? How do we look for the percentile 65? How do we solve for the top 25, lower 65? Okay? We're done with how do we solve for the percentile rank. This time, the other way around. How do we determine the percentile? Okay, the percentile 25, percentile 75, percentile 60, how do we solve that? Okay, how do we solve that? I will stop sharing my slide, and then we will proceed to my whiteboard behind my back. Okay, so on the number of 10 hours of 10, number of hours of 10 randomly selected persons watch TV per day. Okay? So suppose you are given the following data on the number of hours 10 randomly selected person watch TV per day. So these are the data. So we have 2, 2, 3, 4, 4, 4, 5, 2, 6, 6, 7. Okay? 2, 2, 3, 4, 4, 4, 5, 2, 6, 6, 7. So we need to look for quartile 1, 2, and then 3. Okay? The question is, Miss, how do we determine the quartile? Okay, first quartile, second quartile, third quartile. Okay, again, the number of hours of 10 randomly selected person watch TV per day. So we have 2, 2, 3, 4, 4, 4, 5, 2, 6, 6, 7. So we need to look for, we need to determine the first quartile, second quartile, and then third quartile. So how do we do that? First, we need to arrange the given data. So we need to arrange the given data. Can anyone arrange it? Yes? 11 been given? 2, 3, 4, 4, 4, 5, 2, 6, 6, 7. Is it 10 na? 2, 4, 6, ayan, okay. So first we need to arrange the data from lowest to highest, right? From lowest to highest. So arrange the data from lowest to highest. So we have 2, how many 2s? There are 2. And then we have 1, 3. How many 4? There are 3 4s. And then 5, 2, 6, and then 7. Okay? So we have 2, 2, 3, 4, 4, 4, 5, 6, 6, 7. So that's the first procedure. Okay? Arrange the data from highest to lowest. Now, we need to determine the first quartile, second quartile, and then third quartile. Miss, how do we do that? Remember that the first quartile, what is the first quartile? When we say quartile, you need to divide the group in 4 equal parts, right? So that is 1 over 4, which is equivalent to what? What is 1/4? What is 1/4? That is, okay, 25. What about second quartile? That is 2/4, which is equivalent to 50. Tama? 50? And then third quartile, that is 3/4, which is equivalent to 75. Am I right? Okay, so meaning, your first quartile is the same as your percentile 25. Remember that when we say percentile, it divides the group into 100 equal parts. So percentile 25 is the same as the first quartile. Second quartile is the same as percentile 50. And they are the same as decile 5. Okay, same lang yan. Half, half, half. Percentile 50 is the same as the second quartile, the same as decile 5. Okay? Quartile 3 is equivalent to what? Or the same as what? Quartile 3 is the same as, okay, percentile 75. Okay, percentile 75. Now, in determining the percentile, so P is equal to Kn over 100. Okay? P is equal to Kn over 100. P equals to Kn over 100. In determining the percentile, P equals Kn over 100. So in this particular example that we have, we need to look for quartile 1. Okay, quartile 1. So quartile 1. So how do we solve for the quartile 1? So since that quartile 1 is the same as percentile 25, so we can now solve. So P is equal to Kn over 100. Means what is your Kn? Kn is, you are referring to the percentile 25. Percentile 25 is the same as quartile 1. So they are both the same. Their values are the same. Okay? So that is percentile 25. So we have 25 multiplied by how many? How many given data that we have? Ilan daw yan? How many? Okay, 10. Divided by 100. So what is the answer? What's the answer? Okay, 2.5. Round up. 2.5, round up. Okay, 3. Now, going back to the data. So what is your third number? Okay, 3. So the third number is 3. So this is your third number. So your quartile 1 is 3. Your percentile 25 is also 3. Do you get the point? Okay, next. Next. What about quartile 2? How do we determine the quartile 2? Quartile 2 is the same as percentile 50. Okay? Quartile 2 is the same as percentile 50. So how do we determine the quartile 2? The same also as decile 5. They are the same. So their values are the same. Okay, because they are both half of the given parts. Okay, so quartile 2 is the same as percentile 50, the same as decile 5. So how do we determine the quartile 2? So P is equal to Kn over 100. So what is your K? 50 multiplied by 10 over 100. So what is the answer? Okay, fine. Okay, fine. If your answer is a whole number, okay, take note of the condition. If your answer is a whole number, you need to get the average of your fifth number and your sixth number. So in this particular, what is your fifth number and your sixth number in this given? Okay, 4. So this is your 3, 4. So this is your fifth number, and then this is your sixth number. Okay, so you need to add. Okay, you need to add. So if your answer is a whole number, you need to get the average of the fifth and then the sixth number. So that will be 4 plus 4, that will be what? 8 divided by 2. So what is the answer? Okay, 4. Okay, so 4. So 4. So therefore, what will be your answer? What will be your answer? What will be your answer? So the value is, so the second quartile is 4. Okay? So the second quartile is 4. Okay? So the second quartile is 4. Next, what about the third quartile? Yes po. Same lang yun. No problem. You can use it. You can use it. As long as they're the same. Next, quartile 3. Okay, quartile 3 is the same as percentile 75. So we have P is equal to 75 multiplied by 10 over 100. So what is your percentile 75 or quartile 3? Okay, 7.5. So round up. So that will be 8. So what would be your 8th number? What will be your 8th number? Okay, 6. 6. So meaning 6, that will be your 8th number. So meaning below 6 hours, okay, below 6 hours, that is your 75%. Okay? So that is your 75%. So 75% of the 10 people watch TV less than 6 hours. Okay? And then the 25% of the 10 people, okay, watch TV more than 6 hours. So that is the interpretation of that. Okay? So quartile 3, which is 6, meaning, since quartile 3 is the same as the 75 percentile, meaning the 75% of the 10 people, okay, 10 random people, watches TV less than 6 hours. And then the 25% watches TV more than 6 hours. So that's the interpretation. Okay? So that's the interpretation. So going back. So that's how we complete for the percentile. So percentile 20th percentile is the same as the decile 2. 50th percentile is the same as decile 5, and then 70th percentile is the same as decile 7. Okay? So decile separate the data set into 10 equal parts. Okay. Quartile separate the data set into 4 equal parts. So percentile 25, the same as the first quartile. Percentile 50, second quartile. Percentile 75, that will be the same as the third quartile. Okay? Outliers. Okay, what is an outlier? When we say outliers, it's extremely high or low data value. Extremely high or low data value when compared with the rest of the data values. So data values less than quartile 1 minus 0.15 multiplied by the interquartile range, or greater than quartile 3 plus 1.5 multiplied by the interquartile range can be considered an outlier. Okay, can be considered an outlier. Miss, what do you mean by that? Okay, what do you mean by that? So procedure of identifying outliers. First, arrange the data in order and find Q1, Q3. Find the interquartile range, Q3 minus Q1. Multiply interquartile range by 1.5. Subtract the value obtained in step 3 from quartile 1 and add value to quartile 3. Check the data set for any data value that is smaller than quartile 1 minus 1.5 multiplied by the interquartile range, and then larger than quartile 3 plus 1.5 multiplied by interquartile range. Okay, so for example, okay, so here we go. Check the following data set for outliers. In this particular given data, what is your outlier? Again, we're saying outlier, extremely high and extremely low. So in this particular, what is your outlier? In this given data. What is your outlier in this given data? When we say outlier, extremely high or extremely low given data. So in this particular data that we have, data set, 5, 6, 12, 13, 15, 18, 22, 50. So what is your outlier? Okay, 50. Why is it 50? Okay, extremely high, di ba? Extremely high. Obviously, 50 extremely high to the others. Okay, extremely high to the others. So 50 is an outlier. Okay, so 50 is an outlier. So how do we know if 50 is an outlier or not? So we need to check it. Okay, so how do we do that? So the data value is extremely suspect as an outlier. So these are the steps in checking for an outlier. First, find Q1 and then Q3. Okay, so how do we solve for Q1 and Q3? How do we solve for Q1 and Q3? How do we solve for Q1 and Q3? How do we solve for Q1? Q1 is the same as percentile 25. O solve. How do we solve for Q1? Anyone? How do we solve for Q1? Since Q1 is the same as percentile 25, so therefore, okay, Kn over 100. So that will be what? So that will be 25 times 8. Okay, 25 times 8 over 100. So the answer is 2. Now, 2. So it's a whole number. So 2 is a whole number. Kapag whole number, how do we determine the Q1? How do you determine the Q1? If it's a whole number, you add the second number and kapag whole number, add the second number and add the second number and then third number. So get the average of the second number and then the third number. So what's the average of the second and third number? Okay, 9. So therefore your Q1 is 9. Okay, your Q1 is 9. Okay, Q1 is 9. Next, what about Q3 or third quartile? What is your third quartile? Third quartile is the same as percentile 75. So we have 75 times 8 over 100. So what is your answer? 6. Oh, it's a whole number again. Kapag whole number, how do we solve it? Okay, get the average of the 6 and 7. So therefore, what is your third quartile? Okay, 20. Okay, 20. Now, so that's your first step 1. Find quartile 1 and then quartile 3. Next, step 2. Find the interquartile range. So 20 minus 9, so that would be 11. Okay, check. Next, step 3. Multiply the value by 1.5. So 1.5 minus, multiply by 11, so you do have 16.5. Okay, 16.5. So that's the third step. Fourth step, subtract the value obtained in the step number 3, which is 16.5, from Q1 and add in your Q3. So you do have 9 minus 16.5, that would be negative 7.5. And then the other one is 20 plus 16.5, that will be equal to 36.5. So that would be the range. So your range will be negative 7.5 up to 36.5. Again, what is your outlier in the given? 50. Now the question is, okay, yung extremely high na data is 50. Is it an outlier or not? Okay, outlier. Why is it? Bakit outlier? Okay, very good. Since the extremely high value in the given data set that we have is 50, we need to determine if 50 is an outlier or not. So based on the range that we have, negative 7.5 up to 36.5, 50 is not included. It's located outside the 36.5. So therefore, 50 is an outlier. Okay? 50 is an outlier. Kasi wala siya dun sa range na given. So therefore, 50 is an outlier. Okay? Do you get the point? Is it clear? Is it clear, people? Okay. Next. 5 number summary. So first is the lowest value, which is the minimum. Then we have quartile 1, the median. When we say median, is the same as quartile 2, quartile 3, and then the highest value, which is the maximum. Okay, so 5 numbers. We did this one in constructing a boxplot graph. Okay, so what is boxplot? Boxplot is a graph of data set obtained by drawing the horizontal line from the minimum data value to Q1, drawing a horizontal line from Q3 to the maximum data value, and drawing a box whose vertical sides passes through Q1 and then Q3, with a vertical line inside the box passing through the median or Q2. Okay? We need the boxplot to determine if the given data is an outlier or not. Okay? So how do we construct boxplots? So first, find the 5 number summary. Ano yung 5 number summary? Minimum, Q1, Q2, Q3, and then maximum. Okay? Maximum value, minimum value. Next, draw horizontal axis with a scale that includes the maximum and then minimum. Draw a box with the vertical sides through Q1, Q3, and then draw vertical lines. And draw a line from minimum data value to the left side of the box and line from the maximum data value to the right side. So I will explain further. Okay? There we go. So that's a boxplot. Okay? So for example, the number of meteorites found in 10 states of the United States is 89, 47, 164, 296, 30, 215, 138, 78, 48, 39. Construct a boxplot of the data, for the data. Okay, we need to construct a boxplot for the data. Okay, so step 1, arrange the data in order, okay, from lowest to highest. So we have 30, 39, 47, 48, 78, 89, 138, 164, 215, 296. Then find the median. Find the median. So quartile 2 and median, they are the same. So the median is, determine the middle number. Determine the middle number. So since the given data is 10, so even. So there are 2 middle numbers. And that will be 78 and 89. So median is 83.5. 83.5. Third, find quartile 1. So what is your quartile 1? How do we solve for the quartile 1? How do we determine? How do you get 47 as quartile 1? How do you get that? How do we solve for the quartile 1? How do you get 47? Aside from that formula, what else? How do you get 47? Quartile 1 is the same as percentile, 25. So you do have 25 multiplied by 10 divided by 100. So you do have 2.5. 2.5. So kapag decimal, you need to round up. So 2.5, that will become 3. So ano yung third number? The third number is? Hello people? Okay, 47. Now next, quartile 3. Paano naman yung quartile 3? How do we solve for it? Quartile 3. Quartile 3. Oh. Okay, so that will become 7.5. So 7.5, that will be equal to 8. So what is your 8th number? Okay, 164. Okay, then draw the scale now. Okay, so draw. So that's it. So I do have quartile 1, quartile 2, and then quartile 3. Okay, so you draw the scale now. So using the number 9, of course you need to come up with the number 9. Okay, number 9. So we have, let's say we have 100. You can assign numbers here. So 100, 200, and then we have 300. Okay? So we have, what's your minimum value? Ano yung minimum value natin? The minimum value is 30. Let's say for example, nandito si 30. Okay, 30. Okay? So here, that's the minimum value. So it's 30. Okay? And then the other one is, quartile 1 is 47. So 47. Let's say we have 50 here. So yung 47, assuming na nandito. So this one. Okay. Let's say this is your quartile 1. Okay, the 47. Next is, median is 83.5. So 83.5. So 50, 60, 70, 80, for example here. Ano lang, assume lang. Let's say nandyan. So this is your median. Okay? Let's say nandito si 83.5. Assume lang. Yan. Next is third quartile, 164. So let's say nandito si 164. Ipa-plot lang using the number 9. Just plot it using the number 9. Okay? And then your maximum value, the highest is 200. 200 is the highest. 296. So more or less here. So nandito si 296. Okay. Okay. So that's it. So that's it. Okay. Now, we need to determine the inner fences. Okay. So we need to solve for the inner fences. How do we do that? So we need to solve for the inner fences. So inner fences. So we have quartile 1 minus 1.5. Quartile 1 minus 1.5 multiplied by interquartile range. Okay? And then the third quartile plus 1.5 multiplied by interquartile range. So that's your inner fences. Outer fences, quartile 1 minus 3 multiplied by interquartile range. And then quartile 3 plus 3 multiplied by interquartile range. Can you please determine the inner fences and then the outer fences? Can you please determine the inner fences and then the outer fences? What's the inner fences? Can you please determine? Yan. Can you please determine the inner fences and then the outer fences? Quartile 1 minus 1.5 multiplied by interquartile range. What is your interquartile range? Quartile 3 minus quartile 1. What is your quartile 3? What is quartile 3? 164 minus 47. 164 minus 47. So okay, 117. Now, substitute lang. Give me the value of inner fences and then outer fences. Substitute. What's your inner fences? Substitute. Using your calculator, substitute lang. What's the value? Value? 164 minus 1.5 times 11, 117. Ilan? 164 minus 1.5 times 117. How many? That is negative 11.5. Next. What about the other one? Ay, no. Ito lang. Ano yung quartile 1? 47. So 47 minus 1.5 multiplied by 117. So 47 minus 1.5 times 117. Let me check. That is negative 128.5. Yeah, very good. Negative 128.5. Okay, next. So more or less, nandito yun. Let's say this one. Nandito yung si negative 128.5. So this is your inner fences. Okay? Inner fences. And then the other one. Nasaan yung the other one? Q3 plus, what's the answer? 339.5. So more or less, here. Okay? Yan. Next, outer fences. Negative 304. So here, nandito yun, 304. Oh, next. The other one, 304. Negative 304. Next. The other one. Sorry? 500? 515. So more or less here. So that is your box plot. Inner fence, outer fence, and then this is your 5 number summary. So this is your box plot. Okay? So this is your box plot. In this particular given, do we have an outlier? Meron ba extremely high and extremely low? Do we have extremely high and extremely low? Do we have? In this particular given data, meron ba tayong suspect? Which is extremely high or extremely low? Wala, di ba? There's no suspect here. So meaning, there is no outlier. Okay? Wala naman extremely high and extremely low. The given data are merely closely to each other. So there's no suspect data. Okay? When you say suspect data, you are referring to the extremely high or extremely low data. So in this particular example, there's no suspect data. So we cannot identify the outlier. So this is the box. Your 5 5-number summary. So this is your Q3, median, and then you do have minimum value, and then the maximum value. Okay? So that is the box plot. Yes po. We need to look for the inner fences to identify if the given data is an outlier or not, based on the graph. Because sometimes the maximum value can be an outlier. So you need to draw the graph. So kapag lumabas siya dun sa inner fences, so more or less, you do have an outlier. You get the point? So yun lang yun. Just to identify if the given data, if the given suspect data is an outlier or not, using the box plot. Okay? That's all for today, my dear people. So I'll